Welcome, this is your teacher David Garcia, and today we will be working with the slope, particularly parallel lines and perpendicular lines. Now, let's imagine we have two lines. We have a blue line and we have a red line. How do we know if those two lines are parallel? Very easy. The slope of the blue line has to be equal to the slope of the red line. Now, how do I know if these lines are perpendicular? Well, the slope of the blue line will be equal to the opposite reciprocal of the slope of the red line. Now, this is kind of easy, okay? But what does this mean? Let's see a graphical example. Okay, let's jump very quickly backwards to this example. And here I have two lines, the blue line and the red line. The blue line and the red line share exactly the same slope. If you see in here, this is the slope of the blue line, and this is the slope of the red line. So both of them have exactly the same inclination. That's why if you move forward, all right, and you start stretching and seeing these lines all the way up to infinity, you will see that they never touch. And they will never touch because they share, again, the same slope. Now, I'm going to plane here with the slope of the red line. There we go. Now, these two lines are perpendicular. Now, how do I know that? If I check the rise of the blue line, I see that I go up 2 units. And then the run will be 1 unit. So 2 divided by 1 is 2, which is the slope of the blue line. Now let's do the same for the red line. Now, instead of a rise, if you see the inclination for this line will be negative, because instead of going up, we're going downwards. So I go down, and in this case, I just have to go down 1 unit. And then the run will consist of 2 units. So -1 divided by 2 is -1/2, or -0.5. And that is the property that characterizes these two lines to be perpendicular. So let's go back and let's see this with numbers. Okay, in our first example, we saw that the slope of the blue line was 2, and the slope of the red line was also 2. So they are equal, therefore they are parallel. No problem there. On the second example, we saw that the slope of the blue line was 2, and then the slope of the red line was -1/2. So this is where the equality between these two comes into place. 2 will be equal to -1 divided by -1/2. In this case, negative divided by negative will be positive, and 1 divided by 1/2 will be 2. That's the demonstration. So now let's see a problem. Okay, what can we expect, or how can we solve one of these problems? Let's imagine that we are asked to find a parallel slope for this line, or the slope of a parallel line to this line represented here. Well, first of all, if you remember, we need to rewrite this equation into this format so that we can identify what the slope of that line is. So I'm going to begin. Go. By isolating the negative 3y. So I will have 8x equals negative 15 plus 3y. You can do it the other way around. You will get to the same answer. Now, I'm going to move this negative 15 to the other side. So I will have 8x plus 15 equals 3y. Now this 3, that is multiplying the y, will go to the other side, dividing everything. So I will have 8/3 of x plus 15 divided by 3 is 5 equals y. So now I have, let me just rewrite it, my equation, and I know the slope. I know the slope is 8/3. Now, if I want to find the slope of a parallel line, well, based on this idea, they will have to have exactly the same slope. So the slope of a parallel line will be the same 8/3. No problem in there. Now, what happens if they ask me for the slope of a perpendicular line? If I wanted a perpendicular line, well, first of all, I would have to look for the sign. In this case, the 8/3 is positive. So automatically, I know that my perpendicular line will have a negative slope. And now the reciprocal. This is the easy part because I just need to change the location of these two numbers. So instead of 8/3, I will have 3/8. And that's it. This is the slope of a perpendicular line. That's it for today. Thank you very much, and I'll see you in our next video.